This is the ACT Math Manual, section 21, which deals with lines and angles. So this is one of our first geometry sections, and it is probably the most basic geometry section. A lot of what we go over here will just be review, and hopefully we'll be moving fairly quickly. So if there are things that you are unsure of and that you need further clarification on, you're going to have to ask your tutor or do a little bit of research on your own, as I always say in these videos. So 21.1, terminology and symbols. We do need to know what these symbols represent. So when we see this little squiggly L, that just represents a line. When we see a little dot with a capital letter next to it, as opposed to a small letter, which would be a variable, a capital letter usually represents a point, especially if it goes along with a little point. RS would indicate the portion of the line just from R to S, which is known as a segment. So a segment is a portion of a line between two endpoints and also containing all the points in between. So segment RS would contain all of these points. And then if you see something very similar, but you've got this little arrow on the end of the line that had served as the hat of the R and S, this is a ray, and what a ray is basically it is a portion of a line that continues infinitely only in one direction. So ray RS would start at point R and go in the direction of S all the way infinitely with line L. Now in 21.2 we talk about angle formation, angle types. There's not really anything complex here. This just illustrates that when we have an intersection of lines, we do form four different angles. However, you should remember that two of those angles are equal. Angles 1 and 3 are equal to each other. 1 and 3 are equal to each other, and then the other two are actually equal as well. 2 and 4 are equal to each other as well. These are known as vertical angles. 1 is a vertical angle with 3, and 2 is a vertical angle with 4. You probably will need to know that word. You may encounter that on the ACT. Some students know them as opposite angles, and that's acceptable terminology for these as well. You might also want to know that angles 1 and 2, and again, we're talking about in this figure on the left, not this guy on the right. So angles 1 and 2, and then angles 2 and 3, angles 3 and 4, angles 4 and 1. In other words, the adjacent angles, you probably should know that these guys add up to 180 degrees. They are two angles in a line. One angle in a line, second angle in a line. 1 and 2. Angles 1 and 2. They are supplementary. They are known as supplementary. That is the terminology, supplementary. That is the terminology that we use when two angles add up to 180 degrees. Now, if you have segments that have a common endpoint, segments with a common endpoint, what you should know is that angle 1 plus angle 2 equals 360 degrees, and we will address this in a little bit more detail later. So angle 1 plus angle 2 have to add up to 360 degrees. They form a circle, basically. They go all the way around, and then down at the bottom, angles are going to fall into one of four categories. The one on the left, number 5 here, is completed for you. You might want to run through these on your own. Press pause if you do. The angle measure here, x would be equal to 90, and we would call this a right angle. This one, x, is greater than 90, and we call that obtuse. And this one, x equals 180, and the name for that is a straight angle. It's really just a line, but yes, there is a term for that kind of angle. A note on angle naming. So on the ACT, you may see something like this figure on the left where the question just says something like, what is X? And obviously they're asking you for the angle that is formed between side BC and side AC. So between AC and BC. Now, they may also call that same angle BCA or even ACB. And what you need to understand is that it is the letter in the middle that is at the vertex where the angle is formed. So sometimes students get confused as to what angle BCA actually represents. You are going from B to C to A, B to C to A, which means, again, you are capturing this angle in here, which, like I said, over here is just labeled X degrees. Now, straight angles and angles on a line, remember that straight angles, angles on a line, they are supplementary. They add to 180, supplementary, add to 180. And in examples 1 through 3, you can go ahead and do them right now. But keep in mind, none of these should have a algebraic solution. They should all have numeric solutions. In other words, there is an actual number value that you should be writing in these blanks. So I will go ahead and work through these. Example 1, t plus u. This is the easy one. T and u are two angles in a straight line. They are supplementary. So those two equal 180. Example 2, we have to figure out what z is. So this one's a little bit tricky, but if we notice that there is another line over here, there's another line here, and the three y's are all in that line. There's a y here, a y here, and a y here. And therefore, the three y's add up to 180. So 3y, it's y plus y plus y equals 180. Y plus y plus y is 3y, and then 3y equals 180. We divide by 3, and we get that y equals 60. Now that we know that y equals 60, and by the way, there were other places that you could, let me clean this up here. You can also, you didn't have to use that diagonal line. You actually could have used this sort of baseline here. So there's a line there, and there's three y's there. You could use either the three y's I showed you first, or these three y's, 1, 2, 3. It doesn't really matter. So y equals 60. We now have the measure of this angle. The measure of this angle must be the remainder of the 180 degrees. So this would be 180 minus 60, which equals 120. So z does equal 120 degrees. Now, the average of TU, VX, Y, and Z. Almost everybody misses this question, get a lot of answers like 180 or 360 or a lot of random answers, usually when people don't really know how to attack this question. One of the ways that you can attack this question is, and you should keep in mind that geometry questions are also amenable to the tin techniques, to the throwing in numbers techniques. Don't think that just because you're in geometry you can no longer use tin. So I'm actually going to show you what that would look like here, and then I'll tell you how to do this algebraically. So 130, 50. So I'm just throwing in random numbers. Z looks like it's about 130. U look great. U looks like it's about 50. And then let's do 110 for V. That means X is 70. And since we already know what Y and Z are, we'll actually throw in the real values for those. So there we go. So the average of these is going to be 130, that's the T, 50, that's the U, 110, that's the V, 70 is the X, 60 is the Y, and 120 is the Z. I would go right into my calculator. I wouldn't even think about calculating that in my head. So 130 plus 50 plus 110 plus 70 plus 60 plus the 120, and hit enter, and we divide by 6 angles because that's how many we have, and we get 90. So the average is 90. Now you might have just, in going through that, you might have realized how you would do this algebraically, the way that you would do this algebraically is that these two would have to add up to 180. These two would have to add up to 180. T and U are in a line, V and X are in a line, and then Y and Z would have to equal 180. So when we add these all together in the average formula, when we do, T plus U plus V plus X, this is a U, plus Y plus Z all over 6. Well, again, remember, T plus U is 180. So I'm going to replace those two with 180. V plus X is 180. So I'm going to replace those two with 180. And Y plus Z is 180. So 180 plus 180 plus 180 divided by 6 is 540 divided by 6, and we would get the same answer. So that is how you would do example 3 more, I guess, traditionally, or the more correct way. Although tinning there is quite nice, works out very well. Angles around a point, we talked about this on the previous page. Remember that angles around a point add up to 360 degrees. So all of these angles added together, since they make up the entire angle all the way around this point here, these angles would all add up to 360 degrees. Examples 5 and 6, you might want to pause the video and try these on your own. I'm going to go ahead and do them now. So in example 5, remember that this 56 and this angle out here, A, have to add up to 360 degrees because they wrap around this point. So we would simply do 360 minus the 56, and we would get 304. And we could do that in the calculator if we needed to. Now, in terms of example 6, we should be able to see that we already have a 60-degree angle in here, which means the remaining angles 1, 2, 3, 4, 5, 6 would all have to add up to 360 minus 60, which would be 300. So again, there are 1, 2, 3, 4, 5, 6 ends, and they would have to equal 300 degrees. We divide by 6, we get n equals 50. So that is our value of n. Now, next page, which is page 171, intersecting lines. Again, we already talked about this on a previous page. When two lines intersect, we do form 4 angles, 2 pairs of congruent angles. So A and C, these guys here and here, are vertical angles, also known as opposite angles. They are congruent. B and D are vertical angles. They are congruent. And again, going around, adjacent angles, A and B, are adjacent. They are next to each other. They add up to 180. B plus C adjacent, they add up to 180, and so on and so forth. All of the adjacent angles are supplementary, adding up to 180 degrees. In example 1, we're going to use what we just learned to find the value of y. If you want to do it on your own, pause the video. I'm going to use this angle up here and this angle down here. They are vertical angles, so I can set up the equation 3x plus 10 has to equal 4. I'll wait to distribute 4x minus 5. So again, this angle and this angle must be equal. Now 3x plus 10 equals 4x minus 20. I am going to subtract the 3x, subtract the 3x. I end up with an x here. I'm going to add this 20 to both sides. Normally I don't like combining steps like this, but I'm doing it anyway. I don't know why. So I just found that x equals 30. And now what I use, so I've used vertical angles, now I need to use supplementary angles. I can see that this 3x plus 10 and this y are supplementary. Well, 3x plus 10 when x is 30, 3 times 30 plus 10, that is going to equal 100, which means y must equal 180 minus 100, which means y equals 80 degrees. So that is the value of y there. We used a little bit of vertical angles and a little bit of supplementary or adjacent angles. You do need to know what this little symbol means. Almost all students do, which is great. It does mean that lines L and P are perpendicular to each other. Perpendicular. And that means that they form a right angle. And remember what we said. If this angle is 90, that means this angle is 90. And if this angle is 90 and these two angles are supplementary to each other, then this angle must be 90, which means If that angle is 90 and this angle is vertical to that angle, this angle must be 90. So we have 4 90-degree angles. So 1, 2, and 3, the remaining angles there, they all equal 90 degrees. The perpendicular symbol, yes, you can see that little sort of square thingy between two lines. You can also see perpendicularity expressed with this symbol. So if a question says L and then that symbol and P, it's telling you the same thing that this figure is telling you, that L and P are perpendicular. Parallel lines have no point in common. They never touch. They also, we'll talk about this later, they have the same slope as each other. Next page, this is page 172. Parallel lines and transversals. These can be tricky for students. In school, most of you learn something like alternate interior angles and same side interior angles and corresponding angles, and yes, it might help to have some sense of what those angles are and where they are and what they mean and which ones are equal, but I would say that for the purposes of the ACT, you can distill parallel lines and transversals down to big angles and small angles. So when you see two parallel lines, in this case we have M and N are parallel to each other. M and N are parallel to each other. So notice that up here we form 4 angles, A, B, C, and D, and down here we form 4 angles, W, X, Y, and Z. It should be very clear that angle A and angle C are both the small angles in this 4-angle system up here. In other words, those are both acute angles. And then down here, it looks like W and Y are also the small angles. Back up top, we can see that pretty clearly that B and D are the big angles, the obtuse angles, and down here, Z and X are the big angles. All you need to know is that all of the angles that I just highlighted in yellow, the small angles, they are all congruent. All of the angles that I just highlighted in green, the big angles, they are congruent. And then if you take any green plus any yellow, any big plus any small, and you add them together, you will get 180 degrees. They will be supplementary. So as long as you remember that, and as long as the figure is drawn in such a way that you can see which angles are big and small, you should know right away what your angles are that are equal. So I can see a small angle here. I'm just going to mark all the small angles in black, small, 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 small. And then I can see a big angle here. I don't know if you can tell that's a different color. Let me actually use something that maybe is a little bit easier to see. Yeah, no, still no. But that's green, by the way. So I'm marking the big angles in green, big, 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 big. And so now I know, boom, 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 those are all equal. And then the little ones, boom, 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 those are all equal. As long as you remember the rule about big angles and small angles, you should be okay on most of the simpler and maybe medium parallel line questions. The tougher ones, which we're going to see some examples of in a moment, those will require a little bit more, little bit deeper knowledge. So examples 1 and 2, I would go ahead and do these right now on your own and then come back and join us. So in example 1, we have 2 parallel lines and a transversal. So what I'm going to do is I'm going to start by marking in red all of the, that's not red. I'm going to start marking all of the small angles. So this 72 is a small angle, this one's a small angle, this one's a small angle, this one's a small angle. Remember, when I say small, I mean acute. So those are all the acute angles here. Now I'm going to mark in a different color all of the big angles. Okay, so that's pretty much it. So now I have my red angles are equal, my blue angles are equal, and any red plus any blue has to equal 180. Well, red, this is 72 is a red, this Z is a blue, so it's 72 plus Z equals 180. They are supplementary. I subtract the 72 from both sides, I get Z equals 108. So Z has to be 108. Example 2, very similar. I'm going to go through. I'll start by marking my small angles in red, small, 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 small. I will mark my big angles in a different color. That guy's big, that's big, and that's big. So this one's slightly trickier. I have to figure out what I have to use here. The two equations that I know are, actually there's more than two equations, but I know that y plus 3x minus 20 has to equal 180 because that's a big and a small. They have to be supplementary. I know that, but there's nothing I can do right now with that equation because it has two variables. I can't solve an equation that has two variables. But one other thing that I do know is I know that 5x and 3x plus 20, since one is a big, this black angle, and one is a small, this red angle, they have to be supplementary as well. So I can do 3x minus 20 plus 5x, that was not an x, 5x, that has to equal 180. So now I can combine like terms. I get 8x minus 20 equals 180. Add the 20, 8x equals 200, divide by 8, and I get that x equals 25. Now that I have my x, I can just start filling in what these values are. This is going to be 125. This is 75 minus 20, which is 55, and then I actually didn't even need that 55 because I know that the y is a black angle and this 5x is a black angle. I know the y has to be equal to that other black angle of 125. Now in example 3, this is, I suppose, the only place where trying to figure out what your big and your small angles are may fail, and that's when the angles look they aren't really differentiable. You can't really see the difference between these angles here. It's not clear which ones are big and which ones are small. So you might, again, this is where the knowledge of what you learned in geometry class might come into play, and more specifically, it might behoove you to understand what corresponding angles are. So if this angle over here is 91, then this other angle over here has to be 89. Now, what I meant by corresponding angles is when I have a situation in which I have parallel lines and a transversal, any situation in which I have parallel lines and a transversal, I should know that the angles that correspond to each other, in other words, the upper right angle here corresponds to the upper right angle here, they are equal. The upper left angle here corresponds to the upper left angle here, they are equal. The the lower left here corresponds to the lower left here, they are equal. And the lower right here corresponds to the lower right here, they are equal. So this black angle and this black angle, they correspond, and that would be the S and the T. So the T is also 89, and then the U, since it's vertical to the T, would be 89. T plus U is 89 plus 89, which equals 178. Now, the tougher things down at the bottom of page 172, the tougher things that ACT can do with parallel lines is they can give you multiple transversals. So in all the previous examples, we had parallel lines and then just one transversal, but ACT may give you multiple transversals, which is what they're doing in this particular question here. Probably the easiest way to attack this particular example, if you want to take a stab at it on your own, then press pause and then come back and join us. But one of the ways to attack this kind of question is we're going to ignore this line that I just marked in red, and I'm just going to look at what's going on with this line. And in fact, I'm going to extend this line up here and down here so that things get a little bit easier to see. Hopefully they get a little bit easier to see. So now what I should be able to see is that in the system of parallel lines and then this red line, I have this 125, which is a big angle, and then I'm going to mark my small angles in a different color. There's a small angle, and then down here I have a another small angle, and then another big angle, and another big angle, and another small angle here. So now I know that since it's 125 and this red angle down here, the other big angle, that has to be 125 as well. 120, and inside here I have a triangle, so I know there has to be 180 degrees total in there. So 125 and 28, 125, 28 is 153, and then I take that away from 180 and I get 27. So S would be 27. Now again, other ways to do this, one way that some students do and are able to see very simply here is that there is a Z formed here. So actually, let me do this in a different color. I'll do it in whatever color that is, green. So I'm going over, and then I'm zigzagging up, and then I'm going over again here. Whenever you have parallel lines and you see a Z being formed with the two parallel lines and then one of the transversals, you know that the angles in the nooks, in the little bends in the Z, they have to be equal to each other. So this angle up here would be 28. How would you use that? Well, you know that the angles in this area, let me clear some of this out a little bit. Get rid of this. We know that the angles up here all have to add to 180 degrees. So if we already have a 125 and a 28, again, we can just subtract the 125 and the 28 from 180, and that would give us what remains, the S, which is in effect what we did down here also. So, or at least that's the calculation we made down there. Now, next page, these are the toughest of the bunch. If you want a challenge, then pause the video and try these on your own. I'm going to work through them right now. Again, there are multiple ways to do these questions, so if you do them and you get the right answer in your way, good for you. I'm going to show you one or two ways on these questions. So in example 5, what I'm going to do is I am going to show you this one in two different ways. I'm going to extend, so notice these two transversals, they are truncated, they're cut off. I don't see the other ends of the transversals. So if I extend one of the transversals this way, what I can do is, since I know this is 72, the remainder of that angle has to be 108. So now I know one of the angles in this triangle here is 108. I know that this angle is 46, and actually we'll use the little Z trick that we just learned. Boom, boom, and boom. Remember what we said? We said the angles in the crooks or in the bends of the Z have to be equal. So there's a 46. Keep in mind, I can also do this using the whole big angle, small angle model. That would be fine too. I'm just trying to show you some different ways to think about these. So 108 and 46, 108 and 46 would be 154, and then I have to take that away from 180. 180 minus 154 would be 26, so R would equal 26. Now, one other way to do this is to draw a third parallel line. So what I'm going to do is I'm going to draw a third parallel line right through the bend in the two transversals. What that does for me is it separates the two systems so that it might be a little bit easier to see what's going on. So I have this top system where this is 46, and then I have this bottom system made up of this transversal and this R right here. So if I know that this is 46, I know that this other angle down here is 46, not only because of the Z trick, but also because these are, I'm going to continue this up here, these are both small angles, small angle, small angle. So I now know that this angle in here is 46. if I know that the total is 72, I do 72 minus 46, and what do I get? I get 26. So now I know that this angle in here is 26. That's this angle here. And once again, either by the z trick or by the small angle model, I know that r has to be equal to 26 as well. So you can sort of break this up into layers and then separate the two transversals from each other and then connect the two systems through this 72-degree angle. Now, example 6, definitely the hardest of the bunch. This one I am going to do using throwing in numbers. You can do this one algebraically, but it is slightly complicated. I'm going to use the little layer cake trick here. And where I'm going to throw in numbers is in these angles here. These two angles have to add up to 180. I'm going to do 35 and 45. Normally when you do these questions, you want to avoid using any of the typical 30, 45, 60, 90 angles. So this might be something you want to avoid, but on this particular question, it's perfectly fine. I'll probably end up doing this again with different numbers in a second. So now I know that in this top layer, this is 35, which means this is 35 over here. This x has to be supplementary to both this angle and this angle, which means this is 145. That's what the x is. And this y has to be supplementary to the 45. There's a 45 here. There's another 45 here. Y would have to be supplementary to that. So this has to be 135, which means x plus y, which is what the question is asking. The sum would be 280. Now, you might be sitting there going, wait, you just chose random numbers. How the heck do you know that that's allowed? Well, I don't absolutely know that it's allowed, but I do know that throwing in numbers is generally a very solid technique. And if you don't really trust that the 35 and 45 really work, check this out. I'm gonna make this 0, and I'm gonna make this 80. And if I make this 80, what that means about this y down here is that it's 100. And if this is 0 in here, well, remember the x and this angle have to be supplementary. That would mean x has to be 180. Now, I know those numbers are physically impossible. I'm just trying to demonstrate to you the power of throwing in numbers here. And that power really means that we can use whatever the heck we want, whatever's going to make our jobs easiest. Yes, we are probably violating some law of geometry, but we are, I guess, obeying another law, and the fact that we're obeying that other law means we're getting the right answer. 180 plus 100, x plus y, is again 280. It does not matter what we throw in for these two numbers as long as they add up to 80. As long as those two numbers add up to 80, we're going to get the right answer. Number 17 just deals with bisecting. You all should know that to bisect means to cut in half, and it can mean to cut in half a segment. So this is line, let's say this is line L. We would say that line P is bisecting segment RS on line L. And then we can also bisect angles. So if there is a line or segment that comes in and splits an angle into two equal halves, that is a bisecting line or segment. Now 17, I would try it on your own. I'm going to go ahead and do it right now. In the figure below, line M bisects X, Y, Z, and line N bisects R, Y, Z. If X, Y, Z has a measure of 80, what is the value of X? Okay, so they are looking for the value of X. They're telling us that this is the really concrete piece of information, so we're going to use that first. X, Y, Z has a measure of 80. So this entire angle here is 80 degrees. And they tell us that line M bisects that angle, X, Y, Z. So what does that mean? That means that we have 40 degrees here and 40 degrees here. And then this says that, so we took care of that phrase there, this stuff. Now it says line N bisects R, Y, Z. So line N comes in and bisects R, Y, Z. So that means if this whole angle here was 40, that this is 20 and this is 20. So now what I should be able to see is that x goes from here up to here, which means it runs pretty much all the way along line M except for this last 20 degrees. So again, it spans from here all the way to here, and there's this last 20 degrees to get all the way back around to M. 180 degrees in a line, take away that 20 degrees, 180 minus 20 equals 160. So x equals 160. A little bit tricky if you have trouble keeping track of your angles and what's being bisected and so on and so forth. Segment lengths. Segment length questions very frequently just require drawing a nice figure and then breaking up these questions one phrase at a time, as we're supposed to be doing to all questions. Look at number 13. If you want to try it on your own, go ahead and do so. A, B, and C are points on a line in that order. If AB equals 15 and AC is 3 times as long as AB, what is the length of BC? So again, we are going to draw a nice, neat figure here. So they tell us that AB is 15. And they say that AC is, you know what, I'm going to actually adjust that. I'm going to adjust that because I want to draw this as to scale as possible. So AB, this is 15. And then they tell us that AC is 3 times as long as that. So I'm going to make that, like I said, as to scale as possible. AC needs to be about 3 times as long as that. So that is 45. Now, they are telling us that or they want BC, which means we just have to do 45 minus the 15, 45 minus 15, which has to equal 30, and that is BC. Now, some students will get tricked on this question into picking 45 because they're looking at this number and then they're letting their eyes glance back and forth between that number and the answer choices, and they don't either circle the BC or pay attention to the fact that the question is asking for BC and not AC. So if you did by some chance pause the video and do this on your own and get C, it's because you answered what AC was rather than what BC was. That is it for lines and angles. Make sure you know this information well, and if you do have questions, like I said at the beginning, you will need to ask your tutor for some clarification.